Hello, geometry students. Today we're going to talk about the rhombus, which is a special type of parallelogram. Quadrilaterals are all four-sided shapes, and parallelograms are a special kind of quadrilateral with two pairs of opposite sides that are parallel. And under the umbrella of parallelogram are these three special cases. Today we're going to be discussing the rhombus. But before we do, we have to remember all the properties of a parallelogram because the rhombus is a parallelogram, so all these attributes are true of the rhombus as well. Both pair of the rhombus's opposite sides are parallel, both pair of the opposite sides of a rhombus are congruent, both pair of opposite angles in a rhombus are congruent, and all consecutive angles are supplementary in a rhombus, and finally, the diagonals in a rhombus bisect each other. And that's because the rhombus is a parallelogram, so all these features of parallelograms apply to the rhombus. Plus, the rhombus has a couple extra snazzy features that are only true for the rhombus. There's the definition of a rhombus, a parallelogram with four congruent sides. And then there are two theorems about the rhombus, and they both have to do with the diagonals. The first theorem is the rhombus's diagonals are perpendicular, and the second theorem is the rhombus's diagonals bisect those corner angles. So if we have a rhombus, a parallelogram with four congruent sides, then we know that the diagonals are perpendicular, and that means that four little right triangles are formed. If it's a rhombus, which is a parallelogram with four congruent sides, then we know the angles here in the corner get bisected, cut in half. The angle gets bisected, cut in half. So these two parts are congruent to each other. Now remember, because the rhombus is a parallelogram, then we know both pair of opposite angles started out congruent. So ADC and ABC started out congruent, but because it's a rhombus, the angle got bisected. If they start out the same, their halves are going to be the same. So 3, 4, 7, and 8 are all congruent in a rhombus, and 1, 2, 5, and 6 are all congruent in a rhombus. So pause and use those theorems to find the missing angles in this problem. We know that if it's a rhombus, the diagonals are perpendicular, so angles 2 and 3 are 90 degrees. And then we know that these are four little right triangles. We know that the opposite angles start out the same because it's a parallelogram, but they get bisected because it's a rhombus, and so they started out the same, so their halves are the same. And then these two angles are complementary inside the right triangle, or you could use triangle sum. Pause, find X, and then press play for the solution. Here we're going to use the definition of a rhombus, which states if it's a rhombus, then it has four congruent sides. So those measurements are equal, so you can set them equal and solve for X. Pause, find the missing angles, and then press play for the solution. If it's a rhombus, the diagonals are perpendicular, so the measurement of angle 2 is 90 degrees. And we also know that that means four little right triangles are formed. So these two little angles will be complementary inside the right triangle. We also know that we're given this angle's 20, so we know that this, by triangle sum, this has to be 70. And then we know that in all parallelograms, opposite angles start out the same, but in the rhombus, the angle gets bisected, and so their halves are all the same. Pause, find the missing angles, and then press play. In this case, we have a rhombus, but we only have one diagonal drawn in. And we know the definition of a rhombus is a parallelogram with four congruent sides. And so you could imagine these are two isosceles triangles formed. And so you could find it knowing the vertex angle and the two other angles that have to be the same because they're the base angles in an isosceles triangle. Another way to solve the problem would be to remember that if it's a rhombus, this corner angle gets bisected. It's a parallelogram, so these angles started out the same. But it's a rhombus, so it got bisected, so their halves are the same. So there are a couple different ways to solve this one. And that does it for the rhombus. I will leave you with this beautiful picture of a lily and wish you a great day.